Question number 4. A sphere of density rho and radius r rests on the bottom of a tank of water. So you have a tank of water and you have a sphere of radius r and density rho is now resting over here. Okay. The buoyancy force on a sphere is F1. Buoyancy force. How do you calculate the buoyancy force? This is nothing but density of the liquid multiplied by volume of the sphere multiplied by g. Okay. This is nothing but your buoyancy force. That's how we get this one here. See, because density multiplied by volume will give me m, so therefore I get this value. Now let us look at the next question here. Now it says I take one more sphere whose radius is r by 2, which means I take a much smaller sphere over here, and this radius is r by 2, but the density is 2 rho, and the buoyancy force acting on the sphere is F2. F2 here. Okay, so how do I write this one here? Once again, I'll write this as rho liquid into volume. What is the volume over here? 4 by I will write this as V2 multiplied by G over here. Let me call this as V1 over here. Definitely volumes are different. Now what is this being asked? F1 by F2 is equal to 1. Now how do we do this? So what we do is, let us calculate F1 by F2. F1 by F2 is equal to rho liquid into, what is F1? V1 by V1 into G divided by rho liquid into V2. This is same, this is same. So therefore I now get this as V1 by V2. Now what is V1? V1 according to this formula is nothing but 4 by 3 pi r cube, and according to this is nothing but 4 by 3 pi into r by 2 the whole cube. So this 4 by 3 pi goes away here, and thus I am left out this. If I take this ratio, I get this as r cube divided by r cube by 8, which should be equal to 8 over here. Thus F1 by F2 should be equal to 8, which is the right